linear programming using the simplest method. So we were given the mass and the constraint. And to solve question under the linear programming, you must arrive at an optimum solution. An optimum solution is when your Cj minus Zj is equals to 0. So that is our mass, and those are the constraints. First constraint, second constraint, and the third constraint. Now the first thing we need to do is to convert our objective function to standard format. Our objective function is also known as the mass. So to convert the objective function, which is also known as the mass, the first constraint will be equals to 0, the second constraint will be equals to 0, and the third constraint will also be equals to 0. I've been able to convert it to standard format. Now, I need to convert my constraint to standard format as well. So let me convert my first constraint to standard format. To convert my first constraint, the first constraint will be equals to 1, second constraint will be equals to 0, and the third constraint will be equals to 0 too. Now let me convert my third constraint to standard format. So the first constraint will be equals to 0, second constraint will be equals to 1, 1x2, and the third constraint will be equals to 0. While my third constraint, let me convert my third constraint into standard format. This is equals to 70, equals to 24. So to convert my third constraint, first and second constraint will be equals to 0 plus 0x2, and the third constraint will be equals to 1. So I've been able to convert them into standard. Let's input it in the table. So our x1 is 7, 2, and 3. And for our s2 is 5, 3, and 3. So this is our s1, this is for our s2, and this is for our s3. Now, the CB means the coefficient of the objective function, which is the mass. This is the solution mix. The quantity are 70, 24, and 27. x1 and s2 are the real variable. S1, S2, S3 are the slack variable. They are variable that was introduced. So the Zj is the variable of the objective function. And for S1 is 2, for S2 is 5, and so on and so forth. So we have to start with our quantity. As I said, the quantity are 70, 24, and 48. So I'm going to check my slack variable. I'm only checking for my slack variable. S1 have 1 and 0, right? So you're going to write S1. S2 have 1 and 0, right? You're going to write S2. S3 has 1 and 0, right? You're going to write S3. That is how to go to your solution mix. Now, for S1, we want to check for S1 under the objective function. Okay, for S1 under the objective function is 2, for S2 is 5, for S1 is 0, for S2 is 0, and for S3 is 0. That is the Zj, the variables of the objective function. Now, before that, let's solve for the coefficient of the objective function. For S1 is 0, for S2 is 0, and for S3 is 0. Now, the next thing for us to find is to find our Zj. How do we solve for our Zj? By saying 0 multiplied by 70 plus 0 multiplied by 24 plus 0 multiplied by 48. That is how to solve for your Zj. And the final answer here is 0 multiplied by 70. As I said, you multiply 2. 0 multiplied by 70 plus 0 multiplied by 24 plus 0 multiplied by 48, which is 0. So if you do everything here, it's going to be 0 because 0 multiplied by 5 plus 0 multiplied by 3 plus 0 multiplied by 3 again is 0. So everything here will be equals to 0. So let's solve for our zj minus zj. The zj is up there already. This will be dash. So by saying 2 minus 0, which is 2, 5 minus 0, which is 5, 0 minus 0 is 0, is 0, and 0. Now, if you could notice, we have not reached an optimal solution yet. No optimal solution yet. Because our zj minus zj is not lesser than or equals to 0. Assuming we have minus 2 and minus 5. Fine. Assuming everything is 0 and 0. That means we have arrived at an optimum solution. So we are going to pick the highest value, which is 5. So that particular column is our pivot column. That is the entry variable. So we need to solve for our pivot rule, but we need to introduce our ratio. Now 5, 3, 3 are the key elements. They are 5, 3, and 3 because they are part of the pivot column. Those are the key elements. Okay. Now to find our ratio, you are now going to say 70 divided by 5. That is the key element. 24 divided by 3. 48 divided by 3. This is equals to 14. This is equals to 8 and this is equals to 6. Now I'm going to select the lowest number to get my pivot row. Don't forget, when I wanted to get my pivot column, I choose the highest. But in this case, I'm going to choose the lowest. So this particular column, this particular row is my pivot row. So S2 is going to replace S3 because the pivot column is the entry variable and the pivot row is the leaving variable. Okay, the S2 is the entry variable because it is the pivot column. The S2 is going to replace the S3. So the S3 is going to leave. So the S3 is leaving, is the leaving variable. So we need, as we know, the column is our pivot element, which is the entry variable. So S2 is going to replace S3. So we need to do the new S2, new value for quantity S1, S2, S1, S2, and S3. So the old value for our S3 is 48. Then you now divide it by the key element, which is 8. Then for X1 is 3 divided by the key element, which is 8. And for S2, it is 8 divided by 8 because 8 is the key element, is 0 divided by 8 in that particular rule. X2 is 0 divided by 8 and X3 is 1 divided by 8. So our S3 is going to leave and our S2 is coming. So we are using the old value for our S3 to solve for new value for our S2. So this is 0.375. 8 divided by 8 is 1. 0 divided by 8 is 0. And this is 0.125. So now I need to solve for my new S1. So by saying I'm going to solve for the quantity and others as well. So by saying 70 divided by minus, you now open the, let's say 7 for X1, 5, those are the old value, 1, 0, and is 0. Those are the old values. We want to solve for the new values of each. So you're going to open the bracket and said 70 minus the key element, which is 5, multiplied by, so everything will be 5 multiplied by, because that is the key element for that particular rule. So 5 multiplied by 6. 5 multiplied by 0.375. Always in parentheses. 5 multiplied by 1, 5 multiplied by 0, 5 multiplied by 0, and 5 multiplied by 0.125. Then 70 minus 5 multiplied by 6, that's what you need to do now. You need to sum everything together. This is 40. 7 minus 5 multiplied by 0.375. This is approximately to 5.125. And this is 0 because 5 minus 5. So this is 1. This is 0. And this is 1 point. This is minus, not plus. Minus 0.625. So I've been able to solve for my new S1. Now let me solve for my new S2. Not new S3. New S2. And the old value there for quantity is 24. 2, 3, which is for x2, is 0 for x1, 1 for s2, and 0 for s3. So don't forget your negative sign, minus, open the bracket of the key element of that particular rule, which is 8. The key element of that particular rule. Don't forget, s3 is for that particular rule, which is 3, right? Which is 3. Key element for that particular rule of S2, which is 3. Because S3 is leaving and S2 is coming in, right? S3 is leaving and X2 is coming. So the key element of that particular rule is 3. 3 multiplied by 3 multiply. Then you now multiply it by 6. Multiply by 0.375 in parentheses, multiply by 1, multiply by 0, multiply by 0, and multiply by 0.125. So I need to sum everything here together. So this is 24 minus 6 multiplied by 6 is approximately 6. So this is 0.875. 3 times 1 is 3. 3 minus 3 is 0. This is 0. This is 1. And this is approximately minus 0.375. So I've been able to solve for the question. Now the next thing for me is to input them. So the next thing for us to do is to input all this value into our new table for x2, s1, and s2. So I'm going to start with my s1. x2 and s2. So let's go for s1, which is 40 as a quantity, 5.125 is 0, 1 is 0, minus 0.625. Now let's go for our x2. the quantity for our x2 is 6. For s1 for our s2 is 0.375. 1 is 0 is 0 and 0.125. So for our s2, the quantity is 6, 0.875 is 0 is 0, 1 minus 0.375. Now the next thing for us to do is let's check for the coefficient of the objective function. For s1 is 0, for x2 is 5, and for s2 is 0. So let's solve for our zj by saying 0 multiplied by 40 plus 5 multiplied by 6 plus 0 multiplied by 6, which is equals to 30. So I'm going to do this throughout for my x12, which is 1.875. This will be equals to 5. This will be 0. 0 multiplied by 0 plus 0 multiplied by 5 plus 0 multiplied by 1, which is 0. And this is also be equals to 0. So let's calculate our zj minus zj. In this case, you find out that we are going to arrive at an optimum solution because our answer will be lesser than 0 or equals to 0, because 5 minus 5 is 0. So everything is 0. So we have arrived at an optimum solution.